All right, let's get into it. Have you ever really, truly stopped to think about what the internet is made of? I mean, we throw around terms like the cloud or cyberspace, but behind every single click, every stream, every post, there's a massive, tangible, physical network. In this explainer, we're going to pull back the curtain on this hidden world and really dig into the unseen foundation of our digital lives.
So yeah, it all really comes down to this one big question. When you hit send on an email and it goes to someone on the other side of a planet, what actually happens in that split second? It's not magic, not at all. It's an absolutely incredible physical journey. So let's trace that journey together. The very first step of that journey happens at what engineers call the physical layer. And you should think of this as the bedrock, the absolute ground floor of all network communication. It's the point where the digital world we all live in meets the real physical world.
Okay, so before our data can go anywhere, it has to be translated. Your computer, my computer, they all think in a digital language, zeros and ones. But the physical world, the actual wires and the airwaves, they operate on a completely different one. So how in the world do we bridge that gap?
Well, here's the textbook definition, and you gotta admit, it's beautifully simple. The physical layer has one job and one job only. Take the smallest piece of data you can have, a single bit, a 0 or a 1, and get it from point A to point B. That's it. But actually doing that is a monumental task.
And this is the crucial part, translation. The physical layer, it's basically a universal translator. It takes all those abstract zeros and ones that make up your data and converts them into tangible physical signals. We're talking electrical tones zipping down a wire, microwaves shooting through the air, or little pulses of light flashing through a fiber optic cable. This is literally how digital information travels.
So once our bits have been translated into these physical signals, they need a road to travel on, right? And the internet isn't just one single road. It's this huge, sprawling network of different data highways. Let's take a look at some of the most common ones that bring the internet right to your doorstep.
First up is DSL. Now, what's so clever about this one is that for a long time, it was one of the most popular ways to get broadband internet. And it did it by kind of hijacking the infrastructure that was already in pretty much every home, the good old telephone line.
And this process, it just illustrates the whole thing perfectly. So your computer's digital bits, they go to your modem, that's our translator. The modem turns them into high-frequency analog tones. These tones then race along the old-school copper telephone wire all the way to the phone company's central office. And there, a device called a DSLM, which is basically the phone company's giant master modem, translates them back into digital bits so they can continue their journey on the wider internet. Pretty cool.
Okay, let's move on to our next highway, cable. This works on a really similar principle, but instead of using phone lines, it uses the coaxial cables that were originally put in for your TV. And because those cables were built to handle high bandwidth video signals, they just have a much bigger capacity for data. That's why cable internet is often a whole lot faster than DSL.
But what if you live somewhere so remote that there are no phone or cable lines to tap into? Well, that's when our data has to take to the skies and travel by satellite.
So, a signal gets beamed from a dish at your home all the way up to a satellite orbiting, get this, 36,000 kilometers above the Earth. The satellite then beams it back down to a ground station that's connected to the internet. But just think about that distance. That round trip creates a noticeable delay, what we call latency, of about 280 milliseconds. It's an amazing solution for giving people access in remote areas, but it comes with that built-in physical speed bump.
Now, it doesn't matter if a signal is traveling through a wire or through space, it faces a universal problem. Over long distances, it gets weaker. It fades out. It's kind of like a runner in a marathon, It needs a way to get its energy back so it can finish the race.
And that is where this absolutely crucial device comes in, the repeater. The best way to think of it is like a rest stop on the data highway. A weak, tired signal comes in, the repeater listens to it, creates a brand new, clean, powerful copy of that exact same signal, and then sends it on its way. These things are everywhere, and they're essential for getting data across cities, countries, and even under oceans, where thousands of miles of fiber optic cables are lined with repeaters to keep those light pulses strong.
Okay, so we've talked about bits and signals and wires and satellites, but why does any of this matter? Why does understanding this physical layer actually make a difference to our everyday experience of the internet?
Because this, right here, is the main takeaway. The seamless, wireless, in-the-cloud experience that we all know and love, well, it's kind of an illusion. It's an illusion built on top of a very real, very physical foundation. Every single thing you do online, every search, every stream, every share, it starts as a physical signal, traveling a physical path, governed by the laws of physics.
So let's just quickly run through that journey one more time. It starts in your device as pure digital information, zeros and ones. A modem translates it into a physical signal. That signal travels over a physical medium, like a wire or a cable or through the air. It gets boosted by repeaters all along its path to stay strong, and this whole process, happening billions of times a second all over the world, is what creates the internet as we know it.
And that leaves us with a really fascinating final thought. We live in a world that is obsessed with going wireless, right? But as we've just seen, even our wireless signals eventually have to connect back to a physical, wired network. So as our technology keeps evolving, what do you think is the future for the humble cables that still carry the vast, vast majority of our digital world? Something to think about. Thanks for joining me.